What if I told you a moon can be pulled so hard it stretches like chewing gum and even starts to melt from the inside? Stay with me, because by the end you'll see how tidal forces can literally rip a world apart. Maybe you've heard of ocean tides on Earth, right? Now imagine tides so powerful they don't just move water, they squeeze solid rock. That's what happens to some moons, and it's way more dramatic than any tide on our planet. Tidal forces are just gravity behaving differently. The side of a moon closer to the planet feels a stronger pull than the far side. Result? The moon gets stretched into a slight oval, a cosmic tug-of-war happening every single orbit. As the moon orbits, that stretch never lines up perfectly. The bulge is always a bit off-center, so the planet's gravity keeps twisting and flexing the moon. It's like bending a metal spoon back and forth until it heats up and weakens. All that constant flexing turns motion into heat. Inside the moon, rocks grind, crack, and rub. Friction warms the interior, sometimes enough to melt ice or even rock. Suddenly, a frozen world can hide an underground ocean of liquid water. Picture a moon covered in ice, but underneath, a warm, global ocean sloshing from tidal heating. Geysers can burst through the surface like space fountains, spraying water and ice far into space. The quietest world can be secretly active. These forces also sculpt the surface. Cracks, ridges, and strange stripes can all be scars from being pulled again and again. The ground freezes, breaks, shifts, and refreezes, creating patterns that look almost like stretch marks on a world. If the tidal forces get extreme, things get brutal. There's a special zone, the limit, where a moon can't hold itself together. Get too close to the planet, and instead of stretching a bit, the moon can be shredded into countless fragments. Those fragments can form spectacular rings. Imagine a former moon, now a beautiful band of countless icy pieces around its planet. From far away it looks peaceful, but every chunk is a reminder of tidal forces that once tore a world apart. Tidal forces don't just destroy, they can stabilize orbits too. Over time, they slow a moon's spin until the same side always faces the planet, just like our moon and Earth. One hemisphere sees the planet forever, the other never does. This locking also changes the planet. The moon tugs back, raising solid tides in the planet itself. Over millions of years, energy is exchanged, orbits drift, and the entire system slowly evolves like a very slow cosmic dance lesson. Why does this matter for us? Tidal heating might create warm havens for life in places far from any star. A tiny moon in the cold outer darkness could still host liquid water, thanks only to gravity stretching and squeezing it non-stop. Astronomers use these ideas to read distant systems. When we see strange orbits, rings, or cracked surfaces, we can guess the invisible tidal battles happening there. Every scar, every ring, is a clue to how gravity has shaped that world. So next time you look at our moon or think about rings around planets, remember they might be the quiet result of ancient tidal wars. Gravity isn't just holding the universe together, it's stretching, heating, and rewriting entire worlds. Stick around our channel, because in the next video we'll dive into one legendary moon pushed to the limit by tides. If you want to see what happens when this stretching turns a moon into a volcanic powerhouse, you won't want to miss it.